Swayam Prabha. Digital India. Educated India.
Welcome to the course Environmental Impact Assessment, and in today's session we are going to cover resource efficiency, and we're going to look at what methods we adopt within the umbrella of EIA. So the key reference for us for this is like from our text course book which we are following is chapter 17, which deals with resource efficiency. So our coverage for today would include that we are going to look at the definitions and concepts of resource efficiencies, where we'll look at some of the models which are their life cycle assessment, then energy and mass balance concept we'll try to understand, and then we'll also try to understand what's closed loop systems, and then what's waste hierarchy, self-sufficiency, and resilience concept. Further, we'll look into what really we look into while we undertake scoping and baseline studies pertaining to resource efficiency. Further, we'll look into how we undertake impact prediction and evaluation while dealing with this domain. Further, we'll look into the mitigation measures which are available in this domain in a very brief manner, and then we'll look at some of the resource efficiency indicators. So accordingly, the learning outcomes, expected learning outcomes are that after completion of this particular session, you should be able to define all the concepts related with resource efficiency. Further, you should be able to identify various purpose and steps involved in scoping and baseline studies, and you should be able to identify ways, approach to deal with impact prediction and evaluation, and then how you would deal with mitigation. You would conceptually explain that, and then also tell the steps involved in that, or certain methods involved in that. Further, you should be able to identify and list some of the resource efficiency indicators. So understanding resource efficiency, it deals with how carefully resources are used and what kind of waste are generated in the process, and how do you really manage that. And you look at it at all the stages of the project, from project construction to operation till the project is decommissioned or pulled down. So usually, if you'll see this resource efficiency, it's not really taken separate section in EIA, but it's very well integrated in the EIA process. But at the international level, this practice is now changing with IFC Performance Standard 3 suggesting for resource efficiency and pollution prevention in its standards guidelines. So looking into the definitions and concepts involved, we see resource efficiency. What does that really mean? So it looks into the measures of input and measures of output and measures of waste. So measures of input, like what resources it's consuming for various stages, in the stages of construction, in the stages of operation and decommissioning. So how much resource it's consuming. Then you also look into, you measure how much waste is generated in the proposed development. And this again, you look at every stage, how much waste you're generating at the time of construction, what waste you're generating at the time of operation, and when the project is pulled down. So you look into like a resource, if we talk about, you look into how much energy it's consuming, how much water it's consuming, and any raw material what it's using. So how much consumption is there. So you measure that input and you also measure that waste which is generated out of your project. So another concept and a key way of looking into it is life cycle assessment. And what is life cycle assessment means that you look into how is the life of the product in terms of how it is consuming energy and how it's releasing, what kind of waste are releasing. And then within this, you also see the concept of upstream impact and downstream impact. So upstream impact would mean that where and how the material is produced, and how it is produced, how it is processed, and how it is manufactured, and how it is packaged, and how it is transported, and how it is used. So that's upstream impact of the project, what we say. And then there is downstream impact, like it deals with mostly the residual, the waste which is generated, and how the resulting waste are managed. How do you recycle it, reuse it, or you ultimately take it to the landfill site, or you generate energy with that. So how the waste out of your project is dealt with, that deals with the downstream impact. So we have seen upstream impact and downstream impact related with the life cycle assessment. So here in the diagram, you can see the upstream and downstream, and you can look at the product life cycle here. And looking at the product life cycle, you see the material which comes, and then how it is processed, manufactured, and it's packaged, transported, and then it is put to use, and then eventually it is disposed. And then all the process till it is disposed, it is said to be upstream if you want to see diagrammatically. And then after it is disposed, how do we reuse, recycle, and make it as a material again is seen as a downstream. So the purpose here when we deal with resource efficiency is to minimize the use of input and also minimize how much waste is generated. So when we look at life cycle assessments, we measure the environmental impact of the product or the services. So that is what we do. And life cycle assessment, and particularly in context of EIA, is considered the amount of resources that is used for at the different stages of a product or a project. So for example, what do you really choose to use, the typology itself, and to what quantity you want to use. So if you use steel compared to alternative building materials such as bricks or concrete, so you will see that steel has larger embodied energy than the alternative material. So that ways it's less resource efficient compared to the alternative materials here. So that is what the assessment is done when we look at the life cycle assessment. So here again, there's a handbook which you can see, life cycle assessment handbook by Curran. You can see here. So I have, you can look at this particular handbook, which should be available. And there are a lot of standards and guidelines which are available to undertake the life cycle assessment. So international standards are available, technical reports are available. I've just snipped the lists for you. And it is said that life cycle assessment is technically very complex subject, and you can see this handbook available for further guidance in that. Looking at the general methodology which is adopted for this purpose, the kind of framework which is adopted for this, you can look at this diagram. You can see, taken from the Curran's book, you can see the life cycle assessment framework. So you first look at the goal and scope and the definition of it, and then you have intensive inventory analysis, and then you assess the impact. And then inventory analysis, at all these stages there will be interpretation. And then you will be looking at the direct applications like product development and improvement. How do you improve the product? How do you strategically undertake planning? And then how do you take connected with the public policy? How do you do marketing and then the other aspects? So all the policy aspects, if you remember, all the tools we had talked about. So that's how the life cycle assessment framework is taken care of in a very broad manner. And here in this example, you can see the general life cycle flow diagram. Here you can see how the raw material is acquired, and even when the raw material is acquired, there's certain consumption of energy, and then at that stage itself, the waste is produced. And then the material, when it is manufactured after acquiring the raw material, again, the energy is consumed in the manufacturing process, and then the waste is generated. Likewise, you see the product manufacture when all the raw materials come together and the product is manufactured. Again, you have energy consumption and the waste is there. And then when the product is used or consumed, energy is again consumed at that stage, and then you might also find waste. And then when the material is no more usable, then you finally dispose that, and then at that disposition also you consume energy, and then even that produces waste, and that waste can be reused or recycled. So that is how you see the general life cycle flow diagram. So think of like a very simplistic manner. You can think of the television manufacturing, how the raw material is coming for that, what basic raw materials are there, then the final television is prepared, and then how it goes for the consumption purpose, and when you dispose of your television, how do you dispose it, and how it is recycled, or so on. So you can think of a computer as well, or any material with which you deal with. So that would allow you to think of the general life cycle of the product. Again, here in the diagram, you can see the assessment of resource performance of buildings. And this again adopted from the British standard. And here you can see how they're looking at the building life cycle, and looking at the resources, how the resource is being consumed at all the stages. So you can see at the product stage, raw material supply, transport, manufacturing, and then the construction stage, transport, construction, installation process. Also, it's the use stage, how you're using use, maintenance, repair, replacement, and end of the life stage, where you have deconstruction, demolition, transport, waste processing, and then post-project, where you're recycling, recovering, reusing all the materials. So that's what you can see here. So that was about the life cycle assessment. Now familiarizing ourselves with the other concepts, that's energy and mass balance. So this is an important component when we deal with resource efficiency. And when we talk about energy and mass balance, it means the sum of mass going into a system, like the total energy getting into the system, must be equal to what is coming out of the system. So there should be a mass balance, and that sum of energy which goes into the system must equal to the energy which is going out, plus the changes in the composition of that system. So it might be either input and output are equal, or there might be input and plus some changes in the system and the output. So that equates to energy balance. And we, in the process of assessment, we ensure that all these inputs and outputs are accounted for. So you take care of all these aspects when you deal with it. So here in the image, you can see from the example, like how all the resources have been taken care of at various stages, and how the input output has been accounted for. and what kind of input is going how, and none of the arrows are left hanging in the system. So another example you can see here, how the balance is checked, what kind of resources have been put into the system, and what kind of output they are getting it from the system. So you can see these examples. So looking at another concept, you see waste hierarchy, and which looks into self-sufficiency and resilience. So looking at waste hierarchy, the concept is like, how do you really handle waste? So the first idea of handling waste is to reduce the amount of waste which is produced. So you try to reduce, reduction, R for reduction, and then you see how you can reuse the material, whatever waste has been produced, how do you reuse those material, and then you further look into how you can recycle them into a new product. So how out of all the waste, new product can be created. And then if all of these cannot be done, or after that also one can recover the energy from the waste. So whatever is the waste, finally you can convert it into energy. And then after all these things, reduction, reuse, recycle, recovery for energy, once you have done that, then the waste can be sent to the landfill site as a residual remaining waste. So that's about the waste hierarchy. Now, looking at the self-sufficiency and resilience. So what is that? So when we look at self-sufficiency and resilience, the system allows more output to be achieved in the given amount of input. So how you can have system sufficiency, so how you can by whatever input is been given, you are trying to maximize the output from that particular input. So you see example include LED light bulbs, which allow many more lumens per watt than the traditional incandescent bulb. So how efficiently you can use it. So process improvement. So all those deal with self-sufficiency and resilience. As well as in the case of settlement also, you're seeing that these days high density is being much more promoted, given the understanding that it allows resource efficiency in terms of how much energy is consumed, how much energy is shared, so which leads to economical use of those resources. So that was about the definitions and concepts. Now moving on, we'll look at the scoping and baseline studies. So the purpose of scoping and baseline study is that you identify which issues relating to resource efficiencies are important for the project planning and important for the decision making. So you identify the important issues here. So in this stage, you have possible questions which you look into. So while dealing with material, you look into like whether the project will use what material which the project is going to use. Is it very limited, and is it scarce resource? And at what stage you're going to use it, to what quantity you're going to use it, and then and whether you're going to use any harmful material, and do you need to handle it in a very special way. So you need to look at all those aspects here. And then you will also look at, once you understand the resources, you would also look at the impact it might have on the environment. So will that particular usage of the material would lead to how much quantity of material do you need, and how it is going to impact the project. So that all you need to see here. And then further, similarly, the material, then the resources in terms of land. So how much land you're going to use, is it suitable, the land is suitable for the purpose or not, and how much, like when you're looking at the impact, how much footprint you are occupying for the particular project, and whether what kind of land you have taken for that purpose. So likewise, you will look into energy. like how what kind type of energy you're producing in the given context and how you're using, whether it's renewable energy or not, and then whatever energy you're going to use, whether you'll be able to get it from the available infrastructure or you would need additional infrastructure for that, and whatever you're consuming, uh, is this existing system resilient to take care of that requirement of yours? Can that take it or not? So all these aspects, like you would be looking at water, then raising similar questions, like are you building a project in the water scarce area, or you have the capacity to take care of that, fulfill that requirement, and then is the water infrastructure resilient in your context or not? So likewise, you look for the waste, and likewise you will look for the all the other aspects. So there's another example which we see here. I have taken it from EU guidance on environmental impact assessment. So you can see, like I said, rarely it is segregated as a separate section. It's very much inbuilt. So I've snipped a checklist from the EU document, which within itself allows you how during the scoping stage you can undertake the resource assessment. So you can see the point number 2: will construction or operation of the phase use natural resource such as land, water, material, or energy, especially any resource which are non-renewable or are in short supply? So you see how they are looking at the resource efficiency and also looking at the availability of the resource. So the checklist questions like land, especially undeveloped or agricultural land, what's the scenario with water, and what's the scenario with mineral aggregates, whether it's yes or no, and then giving it in a descriptive format. What's the characteristic of the project environment could be affected, and how, and is the effect likely to be significant? Why? So in the checklist method, you're also checking the significance of that particular observations you're making. So likewise, you'll be looking at the forest and timber energy, including electricity and fuels and any other resources which you're using for the purpose. Further, from the same checklist, I have taken how they're dealing with the solid waste during the construction or operation or decommissioning stage. So you can see the spoil, overburden, or mine waste, municipal waste, hazardous or toxic waste, other industrial process, surplus products, sewage, sludge, construction or demolition waste, redundant machinery or equipment, contaminant soils or other material, agriculture waste, any other solid waste. So for all these, you look whether you will be using yes or no, what will be the characteristic of the project environments, will it be affected or not, and then what will be the significance of it. So these kind of checklists are used at the scoping stage to look at the resource efficiency. This example is the inbuilt checklist. The previous one you saw was like a specific checklist, or that can also be integrated with the main EIA report. Other I have taken from resource efficiency best practice checklist. I've also given you the link so that you can download this checklist. So here again, you can see how they have prepared a checklist where they look at the energy, water, and then whether the specific details about that, whether it's going to reduce your energy bills or not, what kind typology is there, and whether you're choosing low carbon heating, and are you going to generate your own power, then how you're going to measure your water use, and what are the installations you're doing for saving water. So all those kind of checklists are there. So that was about the scoping and baseline studies. So those things are available, and I've also given the link to all those examples there. Now moving on, we'll look at the impact prediction and evaluation. So part of it we also saw in the checklist method, how they were looking at the significance of the impact which might happen. So now, in this particular stage, you identify issues significant with respect to project environmental impact. So whether whatever impact you've identified in the scoping stage, you'll try to look at the significance of that impact. And in this stage, you make a detailed prediction what will really happen. You further put it in the detailed study and you look at the significance of the kind of change which will happen. And you also look at whether whatever kind of changes are happening will that need mitigation measures or not. So the examples of how you would look into it include that what would be the quantity of material resources consumed, and you would be looking at the details of its typology, and for every project stage you would be looking at. And then you would be looking at from where the material is coming, from whatever resource you're using, from where it is coming. And then you will be also looking at what kind of impact of any material would have on your project site or the environment. So that all you'll be looking, as you also saw in the checklist. So that would help you in assessment of the significance here. So likewise, for the detailed understanding of the material, you might be looking into various resources, like you might be looking at the land resources, and you have already studied how to evaluate land resources. But here, what you are also doing is quantifying and also looking at it from the resource efficiency point of view. So the detailed pattern you know, aware about, but how you're going to use it in this context, that is what you want to learn here. And then you have to be careful whether these resources are scarce in that particular area wherever your project is coming up. And then similarly, you will look at the energy, the quantity of energy used for the proposed project. And you have to also look at not just the quantity, but the type of energy. What type of energy you're using, whether it's renewable energy form or not, and at what stages you're using, so that you are careful that if it's only for a shorter duration, it might be acceptable. But if it's in the operational stage and it is continuously demand, you might have to look for that. And there's another term when you deal with all the resources is the load profile. So looking at what this load profile mean is the energy needed over time, like how much energy you will need in days, weeks, and year. So you also need to identify the load profile. So what's the load profile of your project at every stage, at the construction stage, at the operational stage, and the decommissioning stage. So you need to quantify and look at it. And you may also familiarize yourself with the embodied energy term. So here, how much energy is being consumed by that particular product would be embodied energy. And then for the project, every stage you have to look at how much embodied energy is really coming up for that particular stage in your project. So likewise, you'll be looking at water, the quantity of water used by used by your project, and what kind of emergency services, how the water will be used, and how it will be used in the wastage also. And then here again you will look at the load profile, and you will calculate this as per the data which is available to you. And you will also look at various sources of water from where you're using it, and look at what's the capacity of the existing infrastructure to give you water resource for your particular purpose. And you need to check whether it's in the resource scarce area. And similarly, you look at the waste, the quantity of waste, what will be generated by your project, and at what stage it will be produced, and then where the waste will go, whether you have the capacity of the area to absorb those waste, or do you have infrastructure to take care of those waste. So those things have to be seen here. And you might be you might reflect upon that all the stages might have different level of impact on the environment. So usually the construction stage might have extensive impact, negative impact. Even the demolition stage might also have major impact by the way it generates waste. So you can also look at varying degree of impact at various stages. So here in this example, we look at the example of airport as given in the book. We look at the example of airports from Australia, Western Sydney, and how they are documenting their material. So, material consumed during the construction of the Sydney airport in terms of tons they have recorded. So, you look at during the earthwork, how much water they're consuming, and then what's the potential source, and then they have also quantified it. Likewise, you see how much asphalt they have used, and then in terms of tons. And then you also see the potential resources from where they are getting it. So even a local resource would also save a lot of energy. And then likewise, you see how they are using concrete, how they are using machinery for operation. So you can look at this example, how that documentation goes on. And then there's another example from a pipeline project. You can see here how they are adopting it, waste, how they're dealing with the waste. So what's the waste code, what's the typology of it, what's the description, from where the source is coming, what's the quantity of the source, and then potential management, how they're going to handle it, and what are kind of facilities they have. So similarly, you can see another example of where they are using, documenting the embodied energy so that they could understand the resource efficiency well. So you can see here how with material and each material, how is the energy, embodied energy, and how it is taken care in various country context. So I have just snipped another life cycle impact assessment for you from the life cycle assessment handbook. So here you can see what's the process involved, and like you see the what kind of mandatory elements are there. So selection of impact categories, category indicator, categorization of the models you're going to use, and then assignment of life cycle impact results. How do you classify them? You look at their significance at that time, and then calculation of category indicator results. So how you're going to see the indicator based on the classification, and then based on that, how do you group and weight it? So we did discuss about grouping and weighting. So when you classify that, and then you see whether it's falling under the very high impact or low impact, and what weightage you give to each of those kind of impact which are happening. So that was about the prediction. Now moving on to mitigation aspect. So resource efficiency is said to be best handled in the initial stage of EIA, and especially when you are dealing with all the alternatives, like where the project should be located, where the resource efficiency can be made at its best, and then also when you're dealing with the design, what materials to deal with, how the technology would be there. So that's the level where you really handle the resource efficiency. So while you're doing it as a developer or the project designer, you need to look at how like what materials you're using, and can there be like less material, can you achieve sufficiency or not, that you need to look at, and whether the project could use less land. So all the resources, can you work in the lesser land, can you work in a more energy efficient manner by the use of technology, can you use materials which are less have lesser embodied energy, and then how do you handle the waste product, and how do you look at the water efficient technology, and how do you have the various techniques to recycle the resources, the water resource, the waste, all that you need to look at. So when you're doing the mitigation, you need to see all these, again, all the concepts what you saw, how you're taking care of all those things. So when you improve technology, you can maximize the efficiency of the resource, and you can also minimize the pollution. So all the concepts of reuse, recycle, all that would come here in your mitigation measure. So now looking at, so that was very briefly on the mitigation point. Now, moving on to resource efficiency indicator. So here I have taken this from assessment of resource efficiency indicators and targets. So I have given you the link. You can download. How it gives you a complete idea about various concepts and also the indicator, and then also how you take care of its resource efficiency part here. So you see that in the initial week, first week of our lecture, we looked at the environmental status. So while we were dealing with the environmental status, we had all the global targets. So resource efficiency also helps us to connect with the global targets. So here you can see that how they have greenhouse gas emissions on top, and how they intend to reduce by 20 to 30% by 2020, 80 to 95% by 2050, and then how it is translating into the use of efficient resource usage, so water usage, actual land use. So all that, how they are looking at the domestic material consumption at different context level. So through biomass consumption, mineral consumption, fossil fuel, metal consumption, nuclear energy, all that you can see how it is being dealt with. And then they also have come up with a DPSIR framework, so which is the drivers, pressure, state, impact, and response framework. So we have studied about drivers, pressures, and state. So there's this framework which in this you try to analyze what are the key drivers of the resources which you're going to use, and then the type of pressures exerted because of what kind of resource you're going to use, what kind of pressure will be exerted on the natural resource and the natural environment throughout the life cycle of the product stages, and then what's the state of the ecosystem in which you're dealing with, whether it is already stressed or it has scope for further development. That also you need to look into, and then what kind of impact it will have, and then what kind of response it will have in return, and then what kind of policy interventions you're going to take, improve in terms of productivity, and then how you're going to deal with specific impacts. So it also provides you the DPSIR framework, how to deal with this, how to understand with this. And then you also have this particular resource. The report also gives you the indicators. So you have resource productivity indicator, and looking at what is this, resource productivity indicators are derived from relationship between drivers and pressures. So like water, and water is the water, and what is the water consumption per capita. So that is what you look at, water consumption per capita, when you're looking at resource productivity indicators. And then you have resource specific impact. So this is another term which is used. So this you can calculate based on the relationship between pressure and impacts. So example, greenhouse gas emissions per unit of primary energy supply. So as per the energy supply, how much is the greenhouse gas emission? So this will help you to understand resource specific impact. So what resource you're using and what kind of impact it will have. So here you can see again resource efficiency indicator you have they have developed a thematic strategy on sustainable use of natural resource, where you have 3 types of indicators which are used for measuring resource efficiency. So you can see indicators to measure the productivity of the use of resources, like resource productivity in terms of what economic value you give to per kg, and then indicator to evaluate the environmental impact of the use of specific resources. Then you have indicators to measure progress in reducing the ecological stress of resource use, like cost per impact. Okay, so you look at that eco efficiency. How do you attain that? So you see that 3 indicators categories which are used to measure resource efficiency. You see the socioeconomic benefits, environmental impacts, and resource use, how they have been used at your place. Further, this report also gives you a list of indicators which are used for evaluation purpose. So again, you can see the category material, energy and greenhouse gas emission, water, land and soil, response indicators. So you can see resource issues, resource, what has been used under material, the range of resources, and then how you use the indicator. So there are certain examples of indicator here, like domestic material consumption, absolute per capita, raw material consumption, like whatever absolute per capita environmental weight consumption, EMC, overall environmental impacts indicator. Then for the biomass also you have similarly, you can see for the metal also recovery use, recycle rates of specific metals. So all those indicators are given which might help you how to look at how efficiently those resources are used. And then you can look at another example here taken from the same report. So evaluation of indicators. So how do you evaluate those indicators? So you might be looking at all these, like how it all the resource category and what issues you're dealing with, and then what is the indicator as you saw in the previous table, and then how you're going to take care of it, like through the policy support or sensitiveness or rebound effects or past trends, future trends, early warnings, how you're going to handle that. And then you can see the in this example how they're looking at the resource efficiency, the green criteria completely fulfilled within the policy support, within the sensitiveness. So all the green would show the matrix you can prepare. Orange criteria partially fulfilled, criteria not fulfilled, so all those red areas. So this is how you can even depict your findings for the resource efficiency. And you also have resource use relevant indicators, basket of resource use indicators. So you see material use, energy use, water use, land use. And then in terms of resource use, you look at the domestic resource use, global resource demand, you look at that, and then kind of environmental impact which it might have at the domestic level and at the global level. So you look at these metrics here. So you look at the material and domestic resource use, domestic material consumption, how it is. So by these standards and your contextual commitment as per the country commitment, you can look at that, what's the raw material consumption rates and so on, and what's the energy footprint, what's the water footprint, what's the actual land demand, land footprints, and so on for resource oriented. So there's another guideline which is available for the purpose, environmental impact assessment of the project. I have given you the link. Here also you can see they have inbuilt and like try to handle this. Point number 1, point 3, point 5, where you look at impact related to use of natural resources. So there they have dealt with it. There's another report which you can refer to, life cycle indicators for resources, product and waste. Here again, you can look at environmental impacts and areas of protection by resource and contributors. So you again see raw materials, space, environmental media, flow resources, how those resources are there, individual contributors accounted, from where that is coming, and then what kind of consumption is there, and what kind of impact is there, and what kind of intervention has to be taken for the protection. So that you can see there's another report which is available which you can refer, land and ecosystem accounts for Europe towards geospatial environmental accounting. So that's it. So summarizing what we covered today, so we looked at the definitions and concepts of resource efficiency, where we familiarized ourselves with different concepts. Then we looked at what we really undertake during the scoping and baseline studies. And then we looked at impact prediction and evaluation, for which we also looked at several other guidelines and examples which are there at the later part. Then we also looked at what we really do in the mitigation, and these are very much aligned with the definition and concepts which you learned. So that fits into the mitigation aspect. And then we looked at resource efficiency indicators, like what all indicators are used in the domain. So that was all for today, and these were the references which we used for this particular session. And further, you can look into all these reports. The links have been provided to you. And winding up, please feel free to ask questions. Let us know about any concerns you have. Do share your opinions, experiences, and suggestions. Looking forward to interacting and co-learning with you while exploring AIA. Thank you.